Okay, so I was here a year ago in April where I talked about the kind of things we were contributing at Qualcomm to open source, and I had a bunch of aspirational things that we were going after. The one thing that I could not say at that point was about a month after the Lenaro talk, we had a massive reorg in Qualcomm involving more than 12,000 people worldwide. And we created the Central Software Organization, which I'm actually responsible for. So a lot of those aspirational things are actually coming to fruition, and I wanted to talk about that. Now, you probably have all, well, most of you know Qualcomm certainly as a cell phone provider, which of course is where we grew big, and a lot of our original technology came from. But we've been transforming to really a general purpose semiconductor company, going after automotive. You probably have all seen the $45 billion pipeline we got lined up around that. We're going after XR. I know that some of you are even wearing those glasses right now. We're going after PC, so pay attention to Build next week. We're going after data center. We're going after IoT. So we're really becoming a general purpose semiconductor company. And as part of that, one of the important things we needed to do was make our software organization scalable. Move from what's effectively a consumer electronic product, right? A handset, a cell phone, to really a product that can scale and that can support products for 15, 10 years. Like those are some of the automotive and IoT requirements. So that's part of the software organization goals. How do we scale? That's my one job, number one. And the other one is how do I become, right, more outward focused on the software side? Because it's all about participating in existing ecosystems. And open source to me is an extremely important enabler. I mean, to me, that's a time to market component. It's actually a cost saver in many, if you do it right, in many ways. So that's what I want to talk about a little bit. Okay, I also know that Qualcomm has this checkered reputation with respect to open source. But I've also hoped that you've seen some of the news articles and you've seen us actually change over the last year. So we're actually doing a lot more upstreaming. We're not quite doing it the way I'd like. Right now, it's still part of the process. As a part, we're doing the development in upstreaming. But things are changing, and things are changing very rapidly. So I mentioned open source, but really the internal moniker that we are using is around developer first. And developer first has many more components to it than just open source. It's an important component, but it's not the only component. So it's also about participating in standards. So we're a lot more active in participating in software standards, and you'll see us going forward be a lot more active in standard participation. APIs, standardized APIs. There is actually a very active movement, both internally as externally, to really standardize APIs across all our platforms. And that's, again, important because that's the way how you scale. And of course, part of the developer first is not just about making the source code available. It's also about making the documentation available. So there's a lot of effort on actually writing developer documentation, which again is historically not something that Qualcomm did. We worked closely with our 5 handset OEMs, and we enabled them very closely with our customer engineering organization. And those 5 customers loved us for it, but this is not how you're going to scale to thousands and potentially millions of developers, right? They need to be self-sufficient, and they need to be able to find their documentation in Google, because that's how developers work, right? If you can't find your answer there, then it doesn't exist. So again, hiding it behind portals, making people sign special licenses, all the kinds of stuff that we'd love to do as an IP company, it just doesn't work. And so a lot of my time over the last 2 years with Qualcomm have been working with our legal and licensing organizations, making them understand that this doesn't work and that this doesn't scale. SDKs, of course, a lot of our value comes out of the SDKs and tools and that we build on it. There's obviously a go-to-market component. But the thing that I want to stress on you here is that developer first for us is not just about open source. There are many other components to it as well. And then, of course, we've been working with Linaro for the last 10 years, and we've been working very closely with you, and that relationship is actually very much appreciated. Obviously, we have the landing team, and the landing team has been actively working on enabling internal code name for it is Hamoa, but our Snapdragon Elite X platform. They've been working with us, obviously, on Android, and so a lot of good work that we've been doing there together. Also with certifications. One thing that's extremely important to me is actually standards like System Ready, and so we've been working closely with Linaro to get all our robotic platforms actually System Ready IR certified. So then another thing that I know surprised a bunch of people is we acquired Foundries.io, and they're actually part of the central software organization. So why did we acquire Foundries.io? Well, first of all, their platform and the servers that they offer. And we actually wanted Qualcomm to be part of that. So they offer, as most of you I think are aware, because clearly a lot of the Foundries.io folks are ex-Linaro folks, they build a cloud-based platform where they basically manage and securely update IoT platforms at scale. Clearly, with our IoT aspirations and our IoT business, that's something that's very interesting to us. But there is another important reason. The reason why I was very interested in Foundries.io was their open source experience and having them help Qualcomm transform. So they're very actively involved with our open source processes, they're very actively involved with our open source teams, and they're very actively involved with something that's called Qualcomm Linux, and I'll talk about that in a minute. We will continue to run Global Foundries as an independent entity. They'll be part of the Qualcomm Innovation Center organization, but they're running as an independent entity, and they will actually continue their business as is. So they will continue to service NXP customers, TI customers, AMD customers, whoever their existing customers are, and they will actually continue to expand that too. But obviously, they will also include Qualcomm platforms. So this is a brief overview of the platform as a service stack that Foundries actually provides. They're called factories, but it really starts off with a lot of the base work that we are doing together here at Linaro, anywhere from Bootstrap, right, to Opte, to obviously the Linux porting, all those kinds of things. And then that forms the basis for an offering where they provide a Yocto distribution, fully integrated with the latest kernel, and then, if you look at Qualcomm, with all the Qualcomm-specific SDKs on top of it. So that's our AI stack, our machine learning stack. This is our robotics stack. It's our vision stack. All these other components that we provide on that. And then on top of that, they actually provide CI/CD loops, device management, attestation, over-the-air update kind of capabilities, all the things that come with the Foundry services themselves. And this is what in the end gets delivered to the customer. So you'll see a whole bunch of announcements. In fact, we made some announcement at Embedded World a few weeks ago, but you'll see a bunch more coming out in September about the kind of offerings that we're planning to give there. Another very important part of what we've been doing over the last year is called Qualcomm Linux, which was really, and it's actually kind of transformational for Qualcomm. Qualcomm, given its background again, consumer electronics, was very much about building a point product, a point software stack for a given SoC. And that, of course, over time, you have so many different SoCs, you've got all these different software stacks, that becomes an unmanageable problem. So one of the things we've very actively been driving is a single software stack supporting many SoCs. So a single Linux supporting all our SoCs, a single camera stack supporting all our SoCs, a single audio stack supporting all our SoCs. And as I said, this is one of the ways to go and address the 10, 15-year scalability problem that we have to deal with. So this is something we're very actively working. All of this stuff will be upstreamed. So that's another big part of it. Now again, as I said, this is a learning thing for us. It's a culture change, so it's going to take us some time. We'll probably make some mistakes along the way, but please bear with us. We'll get there in the end. And please educate us and help us with that as well, obviously. Okay, so what does the software architecture look like? Well, you've all seen these kind of pictures. They're pretty standard. For now, the firmware stack is proprietary to Qualcomm, but here too, we are working with the community. We're looking at Tiano Core, obviously, greater adoption of Tiano Core. We're looking at U-boot, all those kind of things. And then on top of it, the kernel, and then, yeah, all your standard kind of stacks and SDKs. So another key part of it is also the latest Yocto release, right? So as with Linux, align with the latest upstream Linux. It's the same thing for Yocto. Align with the latest Yocto version and align with the standard way of doing things. So we're supporting all the standard meta file formats, and OEMs can add their own to that to basically differentiate or adapt it to their taste. OEMs can obviously still replace the BSP with this. They can put their own Linux kernels underneath it. That's all possible. So here's a more complete picture. So this brings in all the other components, as I said, the vision stack, the robotics stack, the machine learning stack. Now, not all of that will obviously be open sourced, right? The vision stack or a camera stack, for example, is highly differentiated, and this is where we actually do a lot of our, we get a lot of our value from. So that is something we keep proprietary. But a lot of the components underneath it are open source. And even for the camera stack, we certainly have this thought model of like, hey, perhaps the framework should become open source eventually, and then the specific plugins, there we decide which ones we open and which ones we keep proprietary. So here's actually a platform that we announced at Embedded World. It is the robotics platform, RB3 Gen 2. You can actually see it downstairs at the booth when you come in on the first floor, 0th floor here, I think. It runs the Qualcomm Linux stack. It runs the entire Yocto stack, all the things that we've been working on. And so they've got a bunch of interesting demos. And I think that's not the next one, but so with it, with this particular stack and with these devices, we've actually been building a lot of industrial use cases. So that's one area that we're going after in IoT. It's the industrial IoT segment. So there's a whole segment around worker safety and security. So think of it as cameras with AI algorithms that are basically looking at factory workers, whether they are wearing their hard hats, right, as they're supposed to, or whether they're sticking their arms into machines that they should not be sticking their arms in. So again, automated kind of systems, that's something. EV charging is something that we've been working on also closely with foundries. A lot of retail kind of things, keeping track of like whether the shelves full, right? Or even when people are taking things off the shelves that you get notifications that you need to refill, things like that. Warehousing, pallet transfer, and then obviously defection detections, all sorts of standard kind of thing. Again, where vision, AI, and then an IoT application all come together. So here what you see is a sorting machine. And so these are actually rice kernels. And all the ones that don't quite look good are being blown out. So there's an air stream on top of it that will basically look at the rice corn and spit out the ones that are rejected. So this is all running on an RB3 platform. It is using the AI and the vision component. And you can obviously see this runs at a pretty interesting, pretty high speed. So another demo.
We are at the Qualcomm booth at Embedded World 2024, specifically at the Edge AI-based fleet management. So behind me, we have 3 Qualcomm Robotics RB3 platforms that are running a workload that is solving a Rubik's Cube. Currently, the actual workload is running on this node over here, part of the Kubernetes orchestration we're going to show is high availability. Even as we terminate one of the nodes, the workload will continue automatically on the other platforms here. So notice while the Rubik's Cube is being solved, I will go ahead and terminate this workload here, but there is no disruption at all to the actual platform itself. The workload automatically moved to the other node, and there is no discontinuation.
So this resilience, obviously, again, depending on the application, is quite important. And now imagine also all of this running the Foundry stack, so these systems are kept up to date and kept secure, even when they're on the factory floor. So let me quickly change topics a little bit. Again, you've seen me talk about it last year a little bit. And of course, we've been expanding. So we're obviously releasing our upcoming Snapdragon X Elite. But we've also actually been upstreaming all the Linux support for it. It's not a supported product from Qualcomm per se, but it is something that I refer to as community supported. So we're putting all the stuff out there, and we are working with various distributions to get it enabled with them. We're obviously running things like Debian, and you can obviously figure out who are the standard players there. It is workable, you can boot it, people are doing that. We're obviously adding a few more things to it, and even the GPU team has signed up to provide more support for FreeDroid. So basically a good developer platform, and obviously on a very interesting processor. Similarly, we've been doing this on our latest mobile platform as well. So again, lots of upstreaming, both to AOSP, and again, a very interesting platform. And typically what happens in Qualcomm is that these kind of platforms end up in the embedded space as well. So very important for Qualcomm. And again, enabling that open source component allows the community to take this hardware and go and do something interesting with it, and things that we haven't even considered. System ready. Following standardization, and specifically when it comes to bootstrapping a system, is very important because it really makes it easier for the OSV to support many different platforms. And obviously it makes it easy for Qualcomm to slot in without too many changes. So this is something that we've been working on very actively. All the robotics platforms, all the RB platforms. So you saw the announcement of RB3 Gen 2, but there will be an RB4 and RB5 as well. They are all system ready compliant. So if your system runs, if your OS is system ready, IR compliant, you will run on these platforms. Pretty much the same notion as what folks, and I was part of that, what we did many years ago around servers, where we had the same kind of problem, right? We wanted to have one boot standard and then be able to run many different kind of operating systems. Okay, we're also going to actively release it. So we've got the upstream version where we clearly are driving everything into kernel.org. Then we also have a Qualcomm supported version that is derived from that. That's obviously aligns with the LTS versions. And then it slots in a whole bunch of our proprietary driver stacks, like the camera stack, like our ISP stacks, like our AI components, and so on. So that provides you then with that with the actual thing that you can run, and that's supported on the platform. We've done that. So the interesting story here about it too, we've been we call it internally mainlining, or refer to it as an inner source model. And one of the benefits we've been seeing out of it is that bringing up new SoCs is a lot faster because there is so much reuse that you have. And so not all of these SoCs that we've brought up we're going to productize, but we are still going to upstream it. So again, these could become community supported efforts. And obviously, we continue to increase our contributions and our upstreaming efforts. So it's basically showing us, the table is showing us that we're continuing, again, in collaboration with Lenaro, continue to do more and more in upstreaming. And that's also a very explicit goal for the Central Software Engineering Organization. Okay, so what are the key takeaways? So Qualcomm is transforming. Qualcomm is becoming a different company. And as part of that, we're building a software organization that is set out to scale. And open source and developer first is a key component to that. And that is our commitment. We're continuing to do that. And that's also the light that you should see acquisition like Foundries.io and potentially others in as well. So open source software is a key part for Qualcomm and will get a lot more important going forward. So what I do want to call out is please go visit the booth. We've got a bunch of interesting platforms there, including our latest PC, as well as the robotic platforms. And if you want to play with the PC, we've got the Qualcomm Developer Cloud, so I can give you access to that. So again, come and talk to the folks, in the booth. And with that, I am exactly on time. So thank you very much.